Okay, so this is from the higher guide, and we're looking at Pythagoras' theorem. This is page 76 from the higher guide, higher workbook. The company, well, same page in the guide, but these are the questions. So time for us to put it into practice. Okay, so question 1, work out the length of the sides marked with the letter in the following triangles, giving your answer to 3 significant figures, which implies that we're going to be using a calculator. So I've brought my emulator up for this. Pythagoras' theorem states that the hypotenuse squared is equal to the sum of the other two sides squared. So I tend to have a habit of writing my largest side first of all, but it doesn't particularly matter. So that's going to be my first line. I'm then going to use my calculator to evaluate that. So 7.9 squared plus 7.2 squared. So that's going to give me, and I tend to, because this is really just a working step, there's no need to go to decimals with that. That's absolutely fine. And then I'm going to square root my answer to, that's going to be the length squared. So I need to square root my answer. So square root answer is going to give us that. So we can treat that as, well, we can write it like that, 457, and then I'm going to make that clear with the denominator over 4. We could put the decimal there, but there's no need to. So we're going to go to, and I'm going to jump straight to, because I'll put it there. So that's going to be 10.68877. So I'll go 7 dot dot. So I've gone further than I need to. So to 3 significant figures, that's going to be 10.7. Same steps involved here, except for we're trying to find, so I would tend to miss that step out if I'm honest. So I'll put it in anyway. If I'm trying to work out a shorter side, I tend to say that the shorter side squared is equal to the longer side squared minus the other non-hypotenuse squared. They've suggested putting this in as a step, which I'm not a massive fan of, but that's okay. So that would be 8.3. So I would tend to miss that step out. So I'll put a kind of a dotted line through it, just to show that I wouldn't tend to do that in an exam. I would tend to go straight to this step. So I would treat it as 10.7 minus 8.3 squared. So 10.7 squared minus 8.3 squared is going to give me 228 over 5, and they've jumped straight to the square root of that. So the square root of that is going to give me, actually let's go back to my previous answer. So it's going to be the square root of 228 over 5. So if I square root that answer, and again I'm going to write my decimals because I genuinely can't state it enough. In an exam paper, I would always show to a greater degree of accuracy and then go to the degree of accuracy asked in the question. So that to 3 significant figures is going to be 2.60. And I've got a feeling I might have made a mistake, so I'm just going to double check my figures here. That just seems too small, but let's just double check. So 10.7 squared, 10.7 squared minus 8.3 squared is going to give us 228 over 5. The square root of that then is going to give us, there we go. So I might have square rooted that twice. Always sensible to double check your answers. It just looked too small. So that was 6.75277. So I'll go dot dot, and then 3 significant figures. Then that's going to be 6.75. Okay, and then for the final one, so a bit more independence for myself here. I'm going to say that 7 squared is equal to 16.7 squared minus 5.6 squared. Then I'm going to work that value out. And again, I keep missing my decimal out because I'm tapping on my screen. 0.5 minus 5.6 squared that's going to give me, so I would tend to, in my solution, go 24753 over 100. Then I go, z is going to be equal to square root of the answer. So I'm going to go 15.733 dot dot dot. So to three significant figures, that's going to be 15.7. Okay. Question 2. One end of a rope is tied to the top of a vertical flagpole at the height of 12.8. When the rope is pulled tight, the other end is on the ground 4.2 meters from the base of the flagpole. Work out the length of the rope. Given your answer correct to the nearest centimeter. So diagram is always helpful. So we've got a flagpole. The height of the flagpole is 12.8 meters. And when pulled tight, this is the value that we're trying to find out. It is 4.2 meters from the base. So we're trying to work out the hypotenuse. So x squared is going to be equal to 12.8 squared plus 4.2 squared. So I'm going to 12.8 squared plus 4.2 squared is going to be equal to that value, and I tend to write that in like that, and then I'll square root it. So x is going to be equal to square root of the answer. It's going to give us 13.47145 dot dot dot. Giving your answer correct to the nearest centimeter, well, these are in meters, so I'm actually going to my second decimal point because that will be my centimeter value. So that's going to be, and it answers for the answer as that, so I'm going to go 1,347. Okay, question 4. Cindy has a rectangular suitcase of length 45 centimeters and a width of 72 centimeters. She wants to put her walking stick into her suitcase. The length of the walking stick is 125 centimeters. She thinks that the walking stick will fit into one side of her suitcase. Is she correct? Fit into one side of her suitcase. Is she correct? So we will only treat this as a 2D shape. So in effect, we've got 72 there, and we've got 95 there. So there's quite a nice version of this question where we're looking at 3D trig, but this is not 3D trig. We're supposed to just be looking at 2D at the moment. And again, we're trying to work out the hypotenuse. So likewise, x squared is going to be equal to 95 squared plus 72 squared, which is going to be equal to 95 squared plus 72 squared. That's going to give me 14,209. So x is going to be equal to the square root of that. So 119.20. The length of the walking stick is 125. She thinks it will fit. Is she correct? We haven't really got room for the answer. Is she correct? No. And I'll state my reason here. No, as 119.2 centimeters is less than 125 centimeters. Okay, and question 4. This diagram shows a small pool with a radius of 2.8 meters and a height of 1.5 meters. A straight pole is 6 meters long. The pole cannot be broken. Can the pole be totally immersed in the pool? So if we think for it to be totally immersed, it would have to go from there to there. And then if we kind of recreate that as a 2D drawing, That's going to be 1.5, and then that is going to be 2 lots of 2.8, which is going to be 5.6 meters. X squared is going to be equal to 5.6 squared plus 1.5 squared. So that's going to be equal to 5.6 squared plus 1.5 squared. So that's going to give me 3,361 over 100. So if I square root that, square root my answer is going to be 5.79741 ... So can it be totally submersed? No. A similar reason. 5.7. Let's go 5.80. Go 3 significant figures. Meters is less than 6 meters. And that's that page done. So that's topic 76 from the higher diagram, from the higher workbook on Pythagoras' theorem.